All right, let's dive right in. We're going to pull back the curtain on one of the biggest, most important breakthroughs in AI today, something called mixture of experts. You might have heard the term thrown around, but what is it really? Well, it's the secret sauce, the magic ingredient that's making today's most powerful AI models tick. And we're about to find out exactly how it works. So, have you ever stopped to wonder about this? We keep hearing about these absolutely massive new AI models, right? Models with trillions of parameters. So, why aren't they just grinding the world's data centers to a halt? I mean, shouldn't our servers be melting down? How is that even possible? Well, the answer is pretty cool, and it all comes down to a fundamental shift in how we're designing them. Okay, so here's the core of the problem. The old way of building AI, it just wasn't sustainable. To make a model just twice as smart, you had to spend way more than double the money and the energy. The cost and the power demands were just exploding exponentially. The industry was basically slamming headfirst into a wall, which you could call the AI scaling wall. And this brings us to the first big idea we need to tackle, this totally unsustainable growth spurt that AI was going through. Because, to really appreciate how genius the solution is, we first have to get a feel for the massive scale of the problem it was built to solve. Let's try an analogy. A traditional, or dense model, is kind of like a single giant brain. And for every single thought, every little task, the entire brain has to light up and get to work. I mean, sure, it's powerful, but wow, is it inefficient. The new approach, a sparse model, is completely different. It's more like a team of specialists. You got a math problem? You call the mathematician. A question about history? You talk to the historian. You don't need the whole team for every little thing. You just call on the right experts for the job.
And that idea right there, that brilliant concept of using a team of specialists, that's the heart of the solution we're talking about. It's an architecture that fundamentally changes the entire economic equation of building really powerful AI.
So this architecture is called mixture of experts, or MoE for short. And instead of one huge monolithic model, it's a collection of these smaller, specialized expert networks. The key idea here is something called conditional computation. It sounds fancy, but all it really means is that only the most relevant experts get activated for any given task. The rest just sit back and relax. So here's the crucial takeaway, the big idea. MoE lets us decouple the total size of a model from the actual cost of running it. Think about that for a second. We can build a model with a massive number of parameters, a bigger brain you could say, but only use a tiny fraction of its power at any one time. That keeps the energy costs totally manageable. Bigger brain, same energy bill. That's a game changer. So how does this team of specialists actually work in practice? I mean, how does the model know which expert to call on for any specific task? Let's get into the mechanism and see how this really elegant system is all put together. The magic really happens with this one little component called the router, or sometimes a gating network. The best way to think about it is like a smart dispatcher. It's a small, very efficient little neural network, and its only job is to look at the incoming information and decide, aha, for this task, we need expert number 2 and expert number 5. It finds the perfect fit for the job at hand. And you can see the whole flow right here. An input token, which is just a piece of data, like a word or part of an image, arrives. The router takes a look at it, assesses it, and then, in step 3, it picks the best experts for the job, usually the top 2. It then sends that token to only those 2 experts, who get to work on it at the same time, in parallel. Finally, their individual outputs are combined to create the final result. And all the other experts? They just stay dormant, saving a massive amount of energy. Now, it gets even more interesting. There are 2 main ways this whole dispatching thing can work. The first is called token choice. That's what we just described, where each piece of data, each token, gets to pick its favorite experts. But there's another way called expert choice. In that setup, each expert has a fixed capacity, and it basically looks out at all the incoming tokens and claims the ones it's best at handling. It's a pretty subtle difference, but it has a big impact on how the workload gets balanced across the team. And that's exactly why the routing algorithm is so critical. As the source material puts it, the routing algorithm lies at the heart of every MoE system. And that's no exaggeration. A good router makes sure all the experts are used efficiently and learn to specialize in different things. A bad router, though, can lead to some experts getting totally overworked while others do nothing at all. That would undermine the entire system.
Okay, so this isn't just some theory dreamed up in a lab. This is a revolution that's already happening. Let's take a look at the real-world consequences of this incredibly powerful architecture.
The MoE takeover has been unbelievably fast. It really started to kick into high gear around 2020 with Google's G-Shard model. By 2023, you had open-source models like Mixtral making this technology accessible to pretty much everyone. And now, in 2024, it's basically become the default for almost every major new model, from Claude 3.5 all the way to the next Llama.
And listen, this isn't just for chatbots. MoE is being used everywhere. Of course, you've got it in the big language models like Mixtral and, as rumored, in GPT-4, where it enables that trillion-parameter scale. But look at translation. It's helping models understand the nuances across hundreds of languages. And even in computer vision, you can now have different experts that specialize in identifying textures, or shapes, or specific objects, all working together inside the same model.
But you knew there had to be a catch, right? This incredible power doesn't come for free. It introduces its own unique set of challenges and trade-offs that we have to deal with.
Right now, researchers are dealing with three main hurdles. First is expert collapse. That's where the router gets kind of lazy and just keeps sending all the work to its favorite experts, which defeats the whole purpose. Second is latency. Because the model has to access memory in this weird, irregular pattern, it can sometimes slow things down. And finally, just training these things can be really unstable. Getting that perfect balance between all of the experts is a very tricky art to master.
And this all leads to what's known as the developer's dilemma, which is perfectly captured by the CAP triangle: cost, accuracy, and performance. And here's the tough part. You can't have it all. You want to maximize accuracy? Okay, but your cost or performance might take a hit. You want the fastest model possible? Well, you might have to sacrifice a little bit of accuracy. The reality is, you're always making a trade-off. This is the central puzzle that developers are trying to solve every time they build one of these systems.
So Mixture of Experts has given us this incredible path toward building AI with vast specialized knowledge. It's really a system of distinct minds all working together. But as these systems get more and more complex, and their specializations get more and more subtle, it raises a really fascinating final question. What happens when their collective intelligence becomes so advanced that we can no longer tell the individual experts apart?